your presentation.
Thanks, Tony. I'd like to start by, of course, thanking the organizers for giving me the opportunity to talk to all of you about the amazing work we've been doing at the Every Company, making animal proteins using fermentation, or the phrase we like to use is precision fermentation. Because in the food industry, when the Every Company and others, when we first started in the space, we came up with the terminology of precision fermentation to help consumers and customers understand that we're actually doing something that's different from making wine or beer or things like that. We wanted to be thoughtful and say we are using, let's say, recombinant DNA technology without actually saying those words. I want to say my talk today is a little bit different from what we've been hearing. I just want to emphasize, as Tony was mentioning, I'm really happy to be here almost 18 years after my first time coming to this conference at this site. I'm impressed with what I see today in terms of the level of abilities that we have in the Pichia community as far as building strains, getting high production strains, a variety of the knockout lines that Tony's lab has made. I think it's just amazing. And so today what I like to do instead is talk about the Every Company as the commercial application of those kinds of technologies and give you guys some perspective of what it's like being, if you will, at the commercial end of the Pichia space and saying, how do we then take those technologies, this platform, and make products? And I should emphasize that Every is actually selling recombinant egg white proteins produced using this platform at this moment here in the US. So what I'm going to be talking to you about is real life commercial things. So I think everyone here is very familiar with this whole concept that animal agriculture, as shown by these various statistics, is one of the worst things that humans do to this planet. And so the Every Company and others are founded based on the notion that by switching to something like precision fermentation to make animal proteins is a way to move away from this sort of animal agriculture's impact on the planet. So next slide, please. Thanks. So back in 2014, one of our founders, Arturo Elizondo, and others set up this company, Every. Back then we were called Kreps Foods, with, again, the concept of making animal protein without using animals. At the time when the company was founded, they identified egg white proteins as a particular opportunity. And the key there with egg white proteins, and I'll talk more about this in a little bit, but is that these proteins have a lot of function in the food industry. So what we saw was that if we could make the exact same proteins that the animal did, that we'd be able to deliver the performance that the food industry needs. And again, in the early days, working with the Pichia system as well as other platforms, finding, again, the right system to make the right quality. As we were hearing from BASF, there are a lot of options out in the industrial space, and finding the right platform for your application is important. So in this slide, I want to emphasize, again, in our case, we're wanting to make proteins without using animals. There are other ways to do this. We're all familiar with the plant-based systems for making alternative proteins for animal proteins. On the other end of the spectrum, the way I see it, you have what are called the cell-based companies. So the idea there is that if you want to make the protein that consumer wants, and I will use the term consumer and customer differently. So in this case, it's really, what does the consumer want? And unfortunately, we all care about the planet. I say everyone cares about the planet. But consumers, interestingly, the way they spend their money isn't necessarily what's best for the planet. They spend their money on what tastes good, what they enjoy. And so one of the distinctions here is that finding the right platform to deliver the right protein so that the consumer will actually buy it. Because again, we're a company, and many others are too, where we have to earn money. And so to do that, we have to convince consumers that what we're making is what they want, in the sense of it tastes good, it has the performance. So the distinction here is that as a young company, when we were looking to produce alternative proteins, we could look at these three different options, and we came up with precision fermentation as the best option in our case, where we're able to deliver the exact same protein that the animal does, meaning then that the consumer and our customers selling to the consumer are going to be satisfied with what we're making as the alternative protein, whereas particularly in the egg white protein function, there really aren't plant-based proteins that mimic egg white function in the food industry. And so when we started, we realized this was an opportunity for a young company to come in and make a difference, both from a sustainability standpoint, as well as producing something that consumers want, and if the consumers want it, then our customers, meaning the food companies that we sell to, will actually want our product also. Next slide, please. Of course, this all makes sense only if, by using precision fermentation, we're able to make proteins more sustainably. And so I grabbed some information off the web from a couple different sites noted here, where people have done life cycle assessment work looking at egg white proteins in particular, produced through precision fermentation versus coming from the animal. And what you can see from these statistics is that whether you look at greenhouse gas production, land use, or water use, in every case, making these proteins through precision fermentation, in fact, is a much better way to do it as compared to getting the proteins from the animal. Next slide, please. For this crowd, I also wanted to share insights from me personally in the sense of looking over information to say also that Pichia is by far a favorite platform of the food industry now. And what I did is I pulled information from the public records from US FDA to then say, how many companies or how many different filings are there for Pichia? And I broke it down by decades. And so you can see, going back to 2000, or from when I was working at then Diversa, now BASF, we filed in 2006. But the striking thing is that now in this current decade, we were already up to 5 filings, and we're not even halfway through the decade. So the point here is for everyone here, the food industry, the food 2.0 industry likes Pichia. Next slide, please. So focusing more on Every and how we do things. So at Every, we've built out a technology pipeline that is very robust. We've developed our own artificial intelligence system that we've nicknamed Overnaut. Overnaut helps us both with things like strain engineering, process optimization, but also as a food technology company, it also helps us with things like recipe or applications optimization. And through this whole system, we're able to have an incredibly rapid idea to grams of protein needed for food applications pipeline. And the key thing here is, again, in the food world, we have to be able to test these things out where we actually feed, sometimes our employees, but consumers, what we're making in our platform, because that's really the ultimate test, is to say, if we're making the right protein, if we're using it in the right application, it needs to meet that, again, that consumer demand or consumer preference, so that when we eventually are commercial, we'll actually be making money because the consumers will buy what our customers are producing. Next slide, please. Some of you may have seen this in the past. So we have, as I said, we have commercialized some proteins from egg white. We have what we call on the left 2 examples are Every protein that's highly soluble, what we call sensory neutral, so you don't really taste it. And we've been using or selling this protein to beverage companies that use it as a way to provide protein nutrition in their beverages in a way that just wasn't possible before. Because again, in this case, it's animal-free in these applications, and so other systems like this would be soy protein or pea proteins. And if any of you are people who go for that sort of stuff, what you'll appreciate is those proteins tend to be very chalky. They have sometimes off flavors. Our protein has neither of those issues. And importantly, we can also provide that function in a variety of pH conditions, carbonated beverages in the case of the build example. Of course, as an egg white protein company, we want to be able to provide a replacement for egg white. And what you see on the far right there was a commercial limited time offer project we had with a bakery in San Francisco, where they used our Every egg white protein to make a recombinant or make a vegan macaroon. And if anyone is familiar with how macaroons are made, they're definitely not vegan. And that was a big hit. So it's great to see our proteins out in the marketplace and getting that consumer feedback to say that they like what we're making. Next slide. I would then want to share more recently, we've come up with the classic egg replacer. So in this case, we have a liquid product using every protein that when you put it into a skillet, you can fry it up and it looks and tastes exactly like scrambled eggs. Again, in this case, 100% animal-free, cholesterol-free, because we don't need to add any of that. If we click to the next slide, it's not just Every that says this is amazing. Back in December, we had a debut of this product through Chef Daniel Hum at the 11 Madison Park restaurant in New York City. If you're not familiar with the restaurant, it's a 3 Michelin star restaurant. David Hum actually has become vegan, and everything he serves in his restaurant is vegan. And so we delivered our egg replacer product to him, which he then used to make several different dishes, which he served to other celebrity chefs and food critics, etc. And if you can read the quotes, everyone loved it. They were amazed to learn that this, in fact, was pure, 100% animal-free and based on the Every egg white protein product. Next slide, please. I think there should be one before. Yeah. So additionally, we came out just at the end of last year with a product concept that we've nicknamed Protein Nectar. So in this case, it's using that Every protein I mentioned before that's highly soluble. In this case, we can put together a liquid protein concentrate where we get 25 grams of protein in 2 fluid ounces, or 60 mils on the metric side. And again, for those of us, and I have 2 coworkers here from Every. When we taste this, it's basically like honey. Because we put in a little bit of artificial sweetener, but you have no idea that you're eating 25 grams of protein in this little shot of 2 fluid ounces. It's in this format. You can also do whatever you want with it, as far as adding it to your coffee, putting it on even on your salads, things like that. Next slide, please. And so then again, the idea with this is providing protein supplement for people in a very different format from what they're used to. Here, this is literally how it looks in terms of the clarity of the liquid, and again, it has almost no taste to it. Next slide, please. And so wrapping up, this is my last slide. The concept here is that we're able to then deliver this protein in a variety of formats because of its function, its performance. And again, this is about going to where the consumer is and saying, here are all these different ways that we envision the Every protein being available to consumers. Things like jellies, powders, a pump. So we're talking with companies that sell syrups to like the food industry. And so you can have a protein pump, and you could add this protein to whatever food you're interested in. And with that, I'm done. Thank you for your attention. I'm happy to answer your questions.
Joel, thanks for the presentation. Question, how do you address the fear that a lot of consumers have? GMO, you see a lot of things that say non-GMO and things like that. So a lot of people do fear chemistry, biology, all of that. How do you overcome that?
That's an excellent question. I would say, having started my life in the 90s in GM plants, it's a very difficult thing because a lot of that fear is based on emotion rather than logic. So what I've experienced is trying to, I don't want to say argue, but trying to make a point in terms of scientific principles doesn't really work. What we can say in this case is that, again, if you care about the planet, this is a key way to address making society less damaging to the planet. So if you will, I would say, here in the U.S., we haven't encountered real pushback from customers, so the food industry, and in our space, there's Perfect Day doing dairy proteins. I'm sure everyone's familiar with the heme story from Impossible. I'm sure they've talked at some of these previous meetings. What we see in this case is that the benefit to the consumer is very obvious, and so when the benefit is there, for a lot of consumers, that fear is less of an issue. I don't want to say less of an issue, but they see the benefit, so they're willing to accept that risk in this case, as compared to, again, back in the old days for me with GM foods, where there was a perceived risk, but there wasn't an actual benefit to the consumer in that case. And so that was more challenging.
Thank you. For being on the frontier of the food production, so what's your feeling regarding the recombinant proteins or modified proteins? So you're producing the natural one, and both in terms of the regulatory and for the consumption from the consumers. Thank you.
Yeah, excellent question. Yeah, exactly. So our proteins are essentially, so when I've talked to FDA, what they have wanted us to be able to say is we're bioequivalent. So in some cases we're not identical because we have slight glycosylation differences, et cetera. What I can say is that here in the US, there's one view of things, which is from a regulatory standpoint, was the idea here is that in the US, we basically have to show an absence of a hazard, whereas in Europe, it's a very different principle. So focusing here in the US, as long as, if we have a modified protein, as long as we can show that that modification doesn't create any known hazard in the food space, FDA is fine with it.
Maybe I want to add one question here. So if you're talking about variants, and what is a real gene, what is variant? So if you talk about proteins from animals or mammalian proteins from mammalian breast milk, for example, so I'm not sure what is the one which is a wild type and what is a variant. So if you look to many different humans, there are so many natural variants around. So any idea how we should deal with that?
It's funny because I actually had that conversation with an examiner at FDA, and they had the same view because they said, look, when you're making these proteins recombinantly, you have one protein sequence. For those of you not familiar with the chicken genome and chicken genomics, the chicken genome that is in the public domain came from one organism, basically. And that's one of the things, again, back in my day working at Diversa with global diversity out there, how different are these different protein sequences when you scan chickens from around the world? We don't know yet, we'd like to find out. But yeah, exactly. And that's part of the synthetic biology world now, is that we are in that space to then say, what is natural and what is a variant, and that's, I think it's in the eye of the beholder.
So you're producing these recombinant egg white proteins with potentially post-translational modifications. Is there any data or any concerns towards allergenicity, for example, of these Pichia modifications, say glycosylation or anything?
So again, for people who aren't familiar, so there are egg allergies out there, and we own the fact that we're making egg white proteins that are in nature are allergenic. And so again, when our proteins are used in products, what part of the labeling then is to say, if you are allergic to egg, you may be allergic to this product because it has egg protein in it. The exact modifications that we have on our proteins that we've commercialized, from a US standpoint, the regulators they've approved, and I should say all of these have no questions letter from FDA, which means they've reviewed our dossier and they're okay with us saying it's safe. And we've shown, we do the LCMS work on the post-translational modifications, and what we've been able to show is that, again, what Pichia gives us is not a known hazard in the food industry, and it's not a known allergen.
Can you talk a little bit about the current state of the pricing and cost, right? Because that's a big consideration, as you talked about, consumers as well, especially for bulk proteins, right? You're not really making anything super specialized. And where do you see it going next 5-10 years?
Yeah. So all I can say is that we have customers buying protein from us at our manufacturing cost. So I obviously can't go into details about what that is. But I think, again, that's also, if you look at this platform as compared to animal-produced proteins, particularly in the egg world, if you're, again, don't follow this space, things like avian flu with flock culling, so where animals are killed, egg prices can triple in the span of a few months. So for the food industry, they're very excited about what we're able to deliver, because what we can then say is when we're running our biomanufacturing plant, that price is stable year over year in comparison to what they can get right now from the animal. I think that scale is by far one of the biggest drivers for getting costs down. Several other companies in the space are focused on, again, building the scale that we need close to cheap sugar. So in the US, that's in the Midwest, because cheap sugar for us is glucose coming from corn. And exactly, it's just going to take a big investment in scale to get there. And happily, if you're, again, not familiar with what's happening here in the US, there is a big push from the Biden administration to support biomanufacturing in the US. And there's actually a presidential order to build biomanufacturing capacity here in the US.
Yeah. Hey, Joe, it's a great talk. It's really
Thanks.
good to know that Pichia now become more interest to people. But so if get into confidential, don't answer me. Then I'm just curious, for example, for production in Pichia using for this application, is there a ballpark? What kind of expression level people have to achieve to get to be economic?
Yeah, obviously I can't touch on those details, but again, what I can tell you is that we are able to do that. We do have amazing strains. Logan Hurst, who's here from our strain engineering team. We have great titers, and the challenge is again scaling. So I'd say getting the right titers, although it's a lot of work, is manageable. Building the big plants is our next challenge as a company.
Yeah, really great talk. This question might also be confidential as well, but I think a common question with large-scale Pichia fermentation is that you end up getting this green brownish pigment type of thing, which is really difficult to get rid of in a relatively low-cost approach. So I just wonder if you guys figure out a way to efficiently get rid of that, or maybe your market strategy is more focusing on those higher priced product categories.
So what I can tell you is people don't want to buy green eggs or green egg replacers. So, and I remember in the early days when I worked in Shichu back, we all often said green is good for Pichia fermentations, right? Green is not good for our egg products. So yes, we do have a way to remove the pigmentation. I can't go into the details about that exactly, but what I can tell you is that it is not incredibly expensive to do so.
Hi.
Yep.
Another question. So I'm wondering if you have any special requirements by FDA regarding the strain engineering and molecular biology you are doing, so with regards to antibiotic marker-free strain engineering?
Yeah, so the short answer is yes, there are requirements. The additional thing, as you're alluding to, we cannot have antibiotic resistance markers in our strains. I will put in a plug for biogrammatics and mention that their CRE-LOC system is a very useful tool for removing markers. And again, what we have found is getting regulatory approval of strains where we use that platform is possible.
Joel, I was on the boat yesterday, and people commented that precision fermentation was a no-no, and what I heard was it was from the barnyard.
Yeah. Yes.
Can you comment on that?
Yeah. So that's so funny. What Knut's alluding to is myself and others were part of there's a Precision Fermentation Alliance, a trade association, and we had the opportunity to meet with members of Congress and their staffers in the fall. And the term that we learned there that's very popular in Washington, D.C. is to be able to say you're part of the barnyard, meaning you're part of U.S. agriculture. So we're actually talking to members of Congress that are responsible for, here in the U.S. we have a thing called the Farm Bill. Every 5 years it's billions and billions of dollars that go to agriculture. Point being, what they were interested to hear from us is that this whole technology could be viewed as being part of the barnyard because we're using, again, glucose from corn sugar. Corn sugar, of course, comes from corn, and it's jobs in the Midwest. It's more demand for U.S. agriculture. To Knut's point, this concept of precision fermentation, however, again, interestingly, I'll stay away from the political aspect of this. Some of the politicians we talked to said you can't say alternative protein was actually their big no-no. So they said, if you want to talk about new sources of protein in the US, that's great. But if you say you've got an alternative protein that basically gets into culture war statements here in the US, that was a terrible thing. So as long as we could say, look, we're providing more demand for US agriculture, this technology also provides the ability for the US to be more competitive, particularly with China. So some of you may know China has these 5-year plans. Their last 5-year plan literally calls out biomanufacturing as one of their top 3 priorities as a nation. So for us as the US and Europe and others, that's also an important thing to say. We want to be able to have that technology here in the US and in Europe rather than having it outsourced to China as other technologies have.